Our last section in Chapter 5, Section 5.3, is called Using Proportional Relationships. What we're going to do in this section is set up proportions to solve things in real life. But we're going to solve by using what's called indirect measurement. Indirect measurement is any method that uses formulas, similar figures, or proportions to measure an object. Our first example shows how one person can use indirect measurements to measure their bedroom. Okay? A blueprint for Letitia's bedroom uses a scale of 1 to 4. 1 inch is 4 feet on the blueprint. Okay? Her bedroom on the blueprint is 3 inches long. All right, so let's just draw a quick picture of this. Let's say here's a blueprint of her bedroom. On the blueprint, her bedroom is 3 inches long. Here's her actual bedroom. We want to know how long the actual bedroom is in feet. So what we can do is we can set up a proportion. So the scale is 1 inch over 4 feet, because 1 inch on the blueprint represents 4 feet of the actual bedroom. And that's going to equal 3 inches over how many feet? Notice how both inches are in the numerator, both feet are in the denominator. Cross multiply, we get 1x equals 3 times 4, which is 12. That's your answer. Make sure you write it with a unit, since this is a word problem. 12 feet. So her bedroom is 12 feet long in real life. Number 2, on a Wisconsin road map, Kristen measured a distance of 11.5 inches from Madison to Wausau. The scale on this map is 1 inch equals 13 miles. What is the actual distance between the two cities to the nearest mile? So 1 inch on the map is 13 miles in real life. She measured 11.5 inches on the map, and we want to know, I'm going to use D for distance, the actual distance in miles between the two cities. So cross multiply, we get 1 inch times D miles, that's just D. And then 13 times 11.5 is 149.5. That's your answer. Units are miles. So those two cities are 149.5 miles apart. Number 3, on the map of Illinois, the scale is approximately 2 centimeters is 55 miles. Measuring your map, you see Chicago to Springfield is 6 centimeters apart. What's the actual distance? So 2 centimeters on the map equals 55 miles in real life. You measured 6 centimeters on the map. How many miles in real life? Cross multiplying, we get 2x equals 6 times 55, which is 330. Divide by 2, we get x equals 165 units are miles. Please pause the video now and try example 4. All right, there is your work and answer for number 4. Similar triangles also have what's called a perimeter ratio. All right, so we've already talked about similarity ratio in this chapter. So you can see the two triangles are similar. 3 over 6, 4 over 8, 5 over 10, all are the same ratio. Right? 3 over 6 is 1/2. 4 over 8 is 1/2. 5 over 10 is 1/2. And that's why the similarity ratio is 1/2. The perimeter is the same ratio. 3 plus 4 plus 5 is 12. 6 plus 8 plus 10 is 24. 12 to 24 is also 1/2. So if triangles are similar, their perimeters will have the same similarity ratio. How will we use that? Let's take a look at a couple examples. Number 5 says, given the two triangles are similar, find the perimeter of the small triangle over there. All right, if the triangles are similar, we see LM and QR are both in the first two spots there. So I know my ratio is 13 to 9.1. I know the perimeter of the 13 triangle is 36. I don't know the perimeter of the other triangle, so we'll call that P for perimeter. There's our proportion. Cross multiply, we get 13P equals 327.6. Divide that by 13. Our perimeter is 25.2 centimeters. Number 6, given that two triangles are similar, find the perimeter of JKL. All right, so let's draw these triangles out here. We got triangle RST, triangle JKL. I know RS is 22, RT is 23, ST is 15, and JK is 11. So now we know the ratio is 22 to 11, which you can simplify to 2 to 1. So I can set up my proportion 2 over 1 equals, I don't know the perimeter of JKL. So where JKL is, that's the denominator, I'm going to put P. I don't know the perimeter of RST, but I could find it really easily by adding 22 plus 23 plus 15. That would be 60. So this perimeter is 60. That's going to go on the top with the 2. Cross multiply, we get 2P equals 60. Our perimeter of JKL is 30 units. We don't know what the units are, so don't worry about putting anything down there. And finally, number 7. Given that two triangles are similar, the perimeter of RKI is 64. Find the value of X. All right, the only thing we know about RKI is this side, RI, which is proportional to WI. So I can set up my proportion. 16 is to 12. I know the perimeter of RKI is 64. I don't know the perimeter of WQI, so that's just going to call that P. All right, if you want to make this easier on yourself, you could simplify this to 4 over 3. It's not necessary. Cross multiplying, you get 4P equals 192. Divide it by 4. We get the perimeter of WQI is 48. So this perimeter is 48. Remember, what perimeter actually means is that all the sides add together. So now we could do 12 plus 7x minus 2 plus 5x plus 2 equals 48. Combine like terms, we get 12x plus 12 equals 48. Subtract 12, we get 36. And divide by 12, we get x equals 3. You don't need to do this, but if you were to plug that back into our two sides we're missing, this would be 5 times 3 plus 2 is 17, and 7 times 3 minus 2 is 19, and if you add up 19 plus 17 plus 12, you would definitely get 48. All right, that ends section 5.3, and it also ends chapter 5. If you need any extra help on any of these, you can always go back and rewatch any of the 3 screen